Hi guys, I'm Earl Philhauer and I'm between you and lunch, so I'll try to be interesting
So make it quick.
and brief. Yes, sir.
He's got his cards. He can be sassy now.
So I'm
sassed
in.
at PCIe.
Yeah,
That's not fun.
yeah, but how quickly we ask for them back depends how nice you are to me.
That's true.
So I'm a senior manager in the Solutions and Benchmarking Lab here at Virident, and today I've got about 4 different use cases, each one kind of showing a different facet of how the Virident products really are delivering customer value. And they're all slightly different, and I think they're all kind of unique and interesting. We have additional ones on our website, so www.virident.com is a great resource. We're trying actually to increase the number of customer presentations, et cetera, on there too. But without further ado, let me start really with one that I had a lot of focus on and really I think is quite interesting, and it kind of harks back to what Ken was talking about right in the beginning about customers moving from large monolithic systems, scale-up type architecture, to the scale-out and the cluster databases. What we have here is the leading social network for businesses and business professionals who before were running on a series of risk-based systems, proprietary, very closed, very expensive, against a back-end SAN. So all their storage was centralized against a very high-end box, serious replication, serious dollars, serious power, serious cooling. They realized they couldn't scale this. This was not the way they wanted to move, especially because they're a Web 2.0 guy. Scale up is not what they do. They know scale out. They've moved from this specific old style architecture scale up to a scale out where we talk about replacing the centralized storage with server after server of local storage. In this case, it's PCI Express-based Virident FlashMaxes. What this does is it actually, for their specific application, it was a cluster database that's used basically for all of their web page generation, data storage, et cetera. It's actually taken the onus off of the centralized store, gotten rid of it, let them move from expensive RISC architecture servers to commodity, bog standard PC, server architectures, x86s, with local flash. Now that's given them benefits here. Really, IOPS have gone up, but IOPS are just IOPS. They're not actual dollars and cents. What's really important for them is a reduction in latency. So they've increased their capability while decreasing the latency by 3x. And this is actual application latency. It's not just the IOs going against there, but it's the IOs against their database, against whatever they need to do before they can present the results to to the customer on the website. This has obviously phenomenally helped them with scaling too. Instead of scaling up and having to buy a much larger SAN, a much more expensive one, they're able to actually add in granular components, which is the whole idea of scale out. You don't have any central point that you're trying to make really big. Every time you need an extra 10,000 users simultaneous, you put in another box, and that's really the idea here. Got a nice pretty graph on the bottom, but really the key message is
using like FlashMax seller,
this is the base FlashMax 2, and
okay.
the original FlashMax we started with them.
Okay, and then the customer is using. It's not like the customer developed their own storage software to run on these servers. It's actually just running their.
This is running a standard. Well, it's an open source cluster type database. I'm not sure I can name it because then the customer will be very, very obvious and legal will be on my butt. But you can check on our website and you'll probably find it there.
Okay.
So any specific questions here? Because this is really the scale up to scale out architecture that we enable. And scaling out with better performance and better TCO, all the good stuff. It's motherhood and
This is not a cache application. This is
absolutely not a cache. This is direct store.
Okay.
So they're using it, basically the card as the primary data store. In terms of high availability, because it's a cluster database, they have, the triplicates are ready.
So it's a shared nothing cluster.
Exactly.
It is possible with any PCIe flash card out
It's
there.
possible to get something like this. The specific results and really the specific performance is what's happened here. The key message is they didn't just try us. I don't want to badmouth any of our competition, but they did try other solutions. The values really the reason they picked us, a couple reasons. One was our support. We're a startup. They're a Web 2.0 guys. They know how to work with us, and we're definitely going to take care of them. Sustained performance. They like to use, they're using 2.2 terabyte carts today. They're like, as was mentioned before, they're not particularly cheap. So you do want to use as much as possible. You want to fill them up to as high a capacity as you can get, while preserving performance. And as you were using some of the other competitions, the performance degraded a bit too much for their liking. So those were really kind of the high order bits for their decision process. Does that answer your question, or?
Yeah.
Okay.
But the problem is the same. So it's like comparing BMW and Mercedes. You are better in something, probably the competitor is better in.
Understood. Yeah, and that's they're benchmarking, which I can give you benchmarks where I win, and they can give you benchmarks where they win. That's obvious. This is a real customer, so they're really looking at their final application performance. So that's the important part for them, not how many IOPS or whether the peak is better. Hey, Fusion IO has higher writes than us on the peak, but sustained for the real app, that's really where they cared about, and that's where we ended up winning the bake-off.
And the chart on the bottom is latency?
This is latency, I believe, for the
95th
application latency in milliseconds over, they just took, was it RRDMon, the round-robin monitoring tool from some time. I couldn't tell you when. And this is full app stack. This isn't just the I/O. So, even with the hard disk, they weren't doing 250. But their full application was, because each customer request could take multiple accesses. So you'd have a big multiplier.
So that's transaction latency, not disk latency.
Exactly. And again, it's a customer.
It's the 95th percentile of the transaction latency.
Yeah. So the key is, the customer doesn't really care too much about the individual I/O. They're trying to get a web page out to somebody.
Yeah.
And that's the net. That's what they were comparing us.
And you remember when sub-second latency was considered good?
Floppy disk days. Yeah, well, everyone has ADD today, right?
So this customer was
Says the man looking at a room of bloggers that are typing away, twittering away. Crud.
Tweet.
This customer had 200 millisecond latency?
This is full application stack.
But that's transaction latency.
Oh, okay,
Transaction.
gotcha.
So how long between you click your button and you get your updated profile, etc. But so this is scale up to scale out, just like Ken was talking about. Cluster databases, the share nothing architecture. It's a great spot to put local store because the app can handle the local store issues. That was a Linux case. Here we have a Microsoft Exchange server case. We have a global insurance provider in Asia that's recently moved from a very expensive SAN to locally attached and replicated, application replicated PCI Express-based FlashMax 2s for their Exchange hosting. The key metric here is, again, they weren't looking at IOPS, they weren't looking at bandwidth, they were looking at how long does it take for one of their insurance agents to open up an email or actually download, I guess, their new caselet workload. And the key here is, even though it's, you're thinking email, you're thinking, oh my God, can I really put this in a DAS? Microsoft Exchange does have replication. These people, this is not a very onerous task for them to replicate, to set up this replication and give real good user performance. Net, they went from around 100 milliseconds to 2 milliseconds on their specific benchmark, which was opening a series of client emails, I guess. And application level replication, both inside a server and between servers was used. So there was software striping as well as the Exchange log shipping. Benefits, users happy, customers happy because he's actually able to toss out these very expensive big all SANs and save some money and space at the time. So those Prior ones were, Windows and Linux, just kind of the base SSD. Here's kind of an interesting use case talking about the software that Paul was mentioning, FlashMax Connect. So this is a clustered metadata server for a cluster file system. There's a high availability pair, of course, because they have hundreds and thousands of clients that are relying upon these metadata servers to actually access the storage farm. And this storage farm is used for things like media and entertainment, so the render farms, post-production, color correction, you name it. It's something that needs to be fast, highly available, and if it goes down, you're in trouble, and it's costing you money every second it's not there. So there's an HA pair. Prior to installing the Virident...
Store next.
I didn't say that. But...
But it is.
Anyway, so the key here is, they already had HA pair of hardware for the metadata controllers because you can't have one single point of failure, but the metadata was being stored on a very expensive SAN. And this SAN was also being used by the clients to store the bulk data. So the frames, individual frames, the 4K is 24 megabytes per image, and you're doing 120 hertz now. So this is insane amounts of data. So there's a lot of bulk data, and large bulk data, and a lot of really small metadata updates. And that's a really bad combination for hard disk drive-based SANs, because you can optimize for one point, you can't really optimize for both points. And that's where we came in. We looked at this architecture and said, hey, we can get rid of the SAN for the reason you're using the SAN is you need high availability. VHA can do that for you over InfiniBand with a local replication network you see right there. That's a single HA InfiniBand cabling. It's actually,
there's no switch.
There's no switch required.
Yeah.
IB is really cool that way. You can just do back-to-back. It's just like, it's Ethernet with the auto negotiation, right?
Yeah.
So it's really cool that way. So we do replace the SAN for the metadata with local PCI Express-based flash. What that does is that buys you a couple things. And that buys you, first, all your metadata, it's still highly available, but it's off the SAN, meaning you can start sizing that SAN for capacity and throughput as opposed to just IOPS. It's a lot cheaper, it's a lot more cost-effective to be doing that. The other is, thanks to VHA, you're actually getting synchronous replication at microsecond latencies. So Paul mentions it's around 9 additional microseconds on a write, on a synchronously replicated write. Versus just a local write with VHA. What that means is to the application is basically indistinguishable. You're getting this synchronous replication for free in terms of performance. You're also getting the high performance reads. This is all local store. This is all local PCI Express-based flash. So we're talking, hundreds of thousands of small block IOPS, which is exactly what a metadata server needs, because in the end of the day, it's really just a small data, it's a large database of small points that says this file's on this range of blocks, this file's on that range of blocks. So really, that's the key here, that the VHA is enabling PCI Express-based flash to be used in highly available configurations that really affect customer performance in terms of dollars and in terms of just end user satisfaction. And our final use case, this is a credit risk management company. It's a database application under Linux. But I bring this up because it wasn't really mentioned here earlier, but as Virident, one of my most prideful parts was actually being involved in the EMC partnership. So Virident HGST now, we supply EMC with Flash, Extreme SF. Extreme Server Flash. We supply them with several of our PCI Express-based models that they rebrand, that they verify, that they validated, meets all of the EMC requirements, and they sell it as their own. And they have a special software called Extreme SW, which is their own caching application that's integrated with their network storage. For this specific customer, they had a database application against an EMC backend store. Now, nothing wrong with it except, well, it was too slow. This is a standard reason people look at Flash. My database queries are too slow, my updates are too slow, I'm not able to expand, I'm not able to add more clients, I'm looking at massive bills for sizing up my SAN. What do you do? So they called EMC. EMC suggested, hey, keep your SAN, let's put flash inside the servers. Let's actually move this data to where the data is being processed and maintain your investment in the existing SAN. This is exactly what makes sense for the customer. It makes sense for EMC too, because they sell both. The key here is by doing the local caching using the Extreme SW, our partner's caching software, they're able to actually improve their database transactions, the final numbers from hours to minutes. That's the 46x. I mean, at the end of the day, we're talking something that was several hours down to, I think, around 10 minutes for their final report generation. And this obviously is a report that had to be generated on a daily basis. So it's one of those cases where you fire it off at night and pray it's there by 7 a.m. in the morning. And if it's not, oh boy, there's heck to pay. So that's the kind of our partner success story. We have other stories, other use cases on our website. I can also talk to anything else if you've got specific questions or general, actually. Going once, twice, sold. Alrighty. Hey, it's the end of the PowerPoints. Woohoo! I guess I'll be handing off to Mr. Gus.
Oh, now he's Mr. Gus. Huh?
Well, he's my boss, so I have to be
okay.
Mr. Gus.
Thank you for getting a haircut for this, Earl. This is awesome. Okay, well, look, thank you very much. What I would like to offer, if it makes sense, is, well, first of all, thank you to the folks that presented. Hopefully got a good flavor for current technology, a little bit of our direction, and then how the technology has been put to work for customer advantage. And what I'd like to do now is ask if we could have the technical gang come back up. We can pass the mic around. If there's 15 minutes, any questions at all, if there's any other follow-through pieces. As part of that, I also want to introduce Nick Barham. Nick is our new Vice President of Marketing. While he didn't speak today, consider our team available to you, whether it's follow-ups or specific things. Please let us know whatever we can do to help you in any follow-ups. So Kumar, if you could come up, Paul, Rohit. Yeah, if there are questions, yeah, it's fine to leave it rolling. If it's okay, we'll take 10, 15 minutes. I just thought I want to make sure that people have an opportunity. I know we kind of laid out some groundwork of a lot of things, but any other questions? Yes, sir.
Yeah, I'm looking at the specification of the Vcache, and you are basically supporting different, I take it for your website, and you are supporting different Linux distribution. And do you have plans to support other platforms, for example, VMware or Microsoft?
We're working on ESXi.
Okay.
At the moment.
With the same specification, so also support for the Virident cache?
Yep.
Okay.
Yep. They'll all be
Any
transparent.
time frame?
Q1, Q2 of next year, we'll get the other platforms out.
Okay. Are you prepared to say anything about how you're integrating Velobit into Vcache?
Well, the most interesting thing about Velobit is I have their patent around dedupe, a very high performance dedupe, which we're trying to figure out, if there's a way to give customers the dedupe option, because it consumes CPU. If they want to consume CPU, or they want the dedupe.
Yeah, you mean you're trading CPU for making
storage,
the effective size of the cache larger.
Right.
When you say CPU, you're talking about CPU in the
CPU on
card?
the host.
On the host.
So the way the Velobit dedupe works is I consume CPU cycles on the host to run the hash. So the hash is very lightweight. It's not it's not a huge one, but
so it's a weak hash and test.
It's a weak hash.
Yeah.
So is it suitable for primary data? That's going to need some more work. But for a cache,
right.
So we think there's something there. We also think there's some leverage there potentially for HA. And kind of the clustering piece in terms of minimizing the amount of traffic that goes over.
Yeah.
So we think,
especially in like VDI environments where the duplicate rate is going to be really high.
Yeah.
Right. And so we think there's a lot of goodness there. We also think, as a standalone caching product for SSDs that are connected via SAS or SATA, there's a lot of value in it in there as well.
And I assume enhanced I/O is basically just going to die because it was not.
We think it leverages open source caching technology, so it's integrated in the sense that we put an interface on it that allows it to be used more easily with our drives.
Yeah, but it was
but it's not.
It's not impressive.
Yeah, it's not going to replace Vcache. So, so for some customers, it may be useful, sure, but.
Okay.
You know. What other questions? So one thing I wanted to mention from Earl's presentation was when he was talking about the not to be named file system, is that for a clustered file system, a lot of times what really kills the file system and bringing it back online is the FSCK. And using the PCIe flashcards, the FSCK went from like an hour and a half to 4 minutes. So a lot of the big drivers for the customers is when they have to clean up their file system and they have to run FSCK, it can happen in 4 minutes and not an hour and a half. So that in itself is a big driver for those file systems to use PCIe connected flash for the metadata.